rows, and then reprint this so that we can see all of these. So back in the same cell where we set our max columns,
welcome to the 16
columns. Now let's also add one for rows as well. So I'm just going to copy and paste that, but instead of max columns here, I'm going to have this be max rows, and I will run that. And now we will rerun this schema here, and now we can see that column per answer. And these, hey there, how's it going, everybody? In this series, if you download data that comes with a README, then this is usually helpful. We have a, hey there, how's it going, everybody? In this series of videos, we're going to be learning how to use the Pandas library in Python. So Pandas is a data analysis library that allows us to easily read in and work with different types of data. So we can use this to analyze CSV files, Excel files, and other similar formats. So if you're getting into the data science field, then this library is going to be essential to learn. It's one of the most downloaded packages for Python, and that's for a great reason. So not only does it allow us to easily read in and analyze data, but it also run this schema here. And Pandas is a data analysis library that allows us to easily read in and work with different types of data. So we can use this to analyze. Also has great performance since it's built on top of NumPy. And we'll be learning how to do different types of an analysis or of data analysis in this series. So in this video, we're going to be going over how to get Pandas installed, how to download the data that I'll be using for most of this series, and also how to get all of this open in a Jupyter notebook so that we're ready to do some coding and analysis. Now, I'd also like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. So first of all, let's install Pandas. So I'm using a clean virtual environment for this series, but you don't have to use a virtual environment if you don't want to. If you don't know what a virtual environment is, it's a tool to use for this. And we will let this run through. And once we have Pandas installed, then let's also install Jupyter so that we can use Jupyter notebooks. Now, I was a bit hesitant to use Jupyter for this series because some people find it difficult to get the hang of. But honestly, if you're going to be doing a lot of work with Pandas, then it's definitely a nice tool to use for this. So now it's not necessary, so you should be able to follow along with this series just fine if you're using a regular editor. But Jupyter Notebooks allows us to actually see our data more easily by using the browser to print out our data in tables that make it easier to visualize. So I'm going to use it in the series, but you don't have to in order to follow along. So to install Jupyter, I'm going to say pip install, and this is going to be Jupyter Lab. And this is spelled Jupyterlab, Jupyter Lab. So we'll get that installed. I've seen some other tutorials where the data just seems kind of unrealistic and not very relatable. So hopefully using this data will keep people interested and also give you a good idea of what it's like to actually download real data from a source and start analyzing it with Pandas. So to download this data, I have this pulled up here in the browser. We can go over to the Stack Overflow survey results page. Now, this is easy to find if you just Google it, but just to keep things easy, I'll have a link to this download page in the description section as well. Okay, now on this page, you can download the data in CSV form for any year that they have available. Now, I'm going to go ahead and download the 2019 data, which is the top data here. So I'm going to download this CSV here, and then we'll click on download again, and this should go ahead and download this for us. So I'm going to download this CSV here, and then we'll click on download again, and this should go ahead and download this for us. Okay, it did. And now I'm going to open this in my Finder here, and I'm going to unzip this data. It comes in a zip drive. And once that data is downloaded and unzipped, I'm going to go ahead and drag that folder to a folder here on my desktop. And that's where we'll also create a notebook and analyze this data. So, real quick, I don't have this open. Let me open up this Pandas demo folder, and this will open this in Finder. And now I will take the data and drag this into this Pandas demo folder that is on my desktop. So your projects can be anywhere. You can download, but I just created a project folder here on my desktop called Pandas Demo, and it's completely empty except for the data that we just dragged in here. So now I'm going to rename this, since this is kind of a long name here. I'm just going to rename this to Data. That was named Developer Survey 2019, but I'm just going to call that Data so that it's easy for us to find that within our script. Okay, so what files do we have here in the directory that we unzipped in this data directory? Let me make this a little larger here. Okay, so first of all, if you download data that comes with a README, then this is usually helpful. We have a README file right here. It tells you what these other files are going to be. So in this case, we have this survey results public.csv, and that contains the main survey results, one respondent per row and one column per answer. And the survey results schema here has the questions that correspond to each column name in the results. Now, if any of this doesn't make sense, and that contains the main survey results, one respondent per row and one column per answer. And the survey results schema here has the questions that correspond to each column name in the results. Now, if any of this doesn't make sense now, then it will once we open up this data in Jupyter. So I'm just giving a broad overview here. Don't let this overwhelm you by everything that I'm saying here. This will make a lot more sense once we open this up in Jupyter. So let's go ahead and do that. So to open this in a Jupyter notebook, I'm going to go back to my terminal. So I'm going to go ahead and close these Finder windows open here, go back to my terminal, and now within here, I'm going to navigate to my folder where I placed that data. And this should be the same command on Mac, Linux, and Windows. So I'm going to say CD, and I'm going to go to my desktop. This is going to be wherever your project directory is, but mine is in this Pandas demo on my on this server. Okay, so we can see our data folder here that we downloaded and placed in our Jupyter demo folder a little. a little bit ago. But now let's create a new notebook. So to create a new notebook, I'm going to click a folder here that we downloaded and placed in our Jupyter demo folder a little bit ago. But now let's create a new notebook. So to create a new notebook, I'm going to click on New up here at the top right, and then I'm going to use Python 3. And now we can name our notebook. So up here where it says Untitled, I'm going to click here, and I'm just going to call this Pandas Demo, and rename that. Okay, so now we're ready to start using Pandas. So we can import this by saying import Pandas as project direct. I am up here, and it seems like it's taking a second. Okay, there we go. Now, back in our terminal here, this will run a Jupyter server, and you will need to leave that terminal open while you're working in Jupyter. So Jupyter runs in the browser. Okay, so we can see our data folder here that we downloaded and placed in our Jupyter demo folder a little bit ago. But now let's create a new notebook. So to create a new notebook, I'm going to click on New up here at the top right, and then I'm going to use Python 3. And now we can name our notebook. So up here where it says Untitled, I'm going to click here, and I'm just going to call this Pandas Demo, and rename that. Okay, so now we're ready to start using Pandas. So we can import this by saying import Pandas as PD. Now, importing Pandas as PD is just a common convention when using Pandas. So let's run that. It's as Pandas as PD. Now, importing Pandas as PD is just a common convention when using Pandas. So let's run that. And I ran that. That cell by pressing Shift and Enter. And again, I'm not going to go into the specifics of working here within Jupyter in this series, but if you'd like a rundown of the features and shortcuts that I'll be using, then I do have a link to my Jupyter video in the description section below. Okay, so for the rest of this video, we'll see how to load in our data and look at some information about that data. So our data is in a CSV format. So in order to read in that CSV, we can simply say df, which is going to stand for data frame. We'll learn all about data frames here in a bit. We're going to say df is equal to pd.read_CSV. We're going to use the read CSV method from Pandas here. And now we just want to pass in a path to our CSV file. Now mine was within that data folder, and that was within the file survey_results_public.csv. So now if I hit Shift Enter, then that will run that cell. So right off the bat, we can see that this is pretty simple to work with. So when using native Python, in order to read in a CSV file, we need to use the CSV module to create a CSV reader and things like that. But here, we're just doing this all in one line. So when it reads this in, it's going to read it in as a data frame. So data frames are pretty much the backbone of Pandas, and we'll go over data frames and series objects in depth in the next video. But for the basics, a data frame is basically just rows and columns of data. We can see what a data frame looks like, but just by printing it out. And this is the great thing about using Jupyter Notebooks, because it allows us to visualize these things in ways that we can't do in other editors. So here in Jupyter, I can simply just say df and run that, and it will print out our data frame here. So we didn't even need to wrap this here in a print function. Now, if you're using a normal editor, then you can still print out data frame information, but it's not going to look as good as it does here in Jupyter, where we get this interactive table. So this is a small look at our data. Now, this is actually 85 columns here, but if I scroll through these, then it doesn't look like there's actually 85 columns printed out here. So this is actually concatenated by default just to give us a broad overview of the data. So by default, Jupyter is displaying 20 columns from our data frame. Now, how did I know that there was 85 columns for this data frame? Well, there are a few attributes and methods that we can use to get an idea of what our data looks like. So first, we have the shape attribute, and shape gives us the number of rows and columns in a tuple form. So let's look at this. So in our next cell down here, I'm going to say df.shape, and I will run that. Now, this is an attribute here. It's not a method, so you don't want to put parentheses. So df.shape, and we can see that we have 88,000 rows and 85 columns. Now, if you wanted a bit more information, then we can use the info method. The info method will give us the number of rows and columns, and also all of the data types of all the columns as well. Now, before I run that, it looks like my text is getting cut off here a little bit. Sometimes this happens whenever I'm within Jupyter. In order to fix this, I usually just come up here and restart and run all my cells again. That usually takes care of the problem. Let's see if that works. Okay, so that seemed to work. Another thing that you can do here is just to totally reload the page in the browser. And when you reload the page, I think it's just because of how I have this text enlarged, so it's kind of messing with how these look, but now we can see these just fine. Okay, so like I was saying, we can see here that we have 88,883 rows and 85 columns. Now, if you wanted more information, then we can use the info method. Method. I have to do here is just to totally reload the page in the browser. And when you reload the page, I think it's just because of how I have this text enlarged, so it's kind of messing with how these look, but now we can see these just fine. Okay, so like I was saying, we can see here that we have 88,883 rows and 85 columns. Now, if you wanted more information, then we can use the info method, and that will give us the number of rows and the number of columns, but also all of the data types of the columns. So let's run that. So if I do df.info, now this actually is a method, so we do want to put the parentheses there. And let me run this, and now let's go over this output. So we can see here that it says that we have 88,883 entries, so those are our rows. We have a total of 85 columns, and then it lists all of our columns here for our data. So these are all the columns in our CSV file that we have loaded in. Now, it also gives us the data types of each of these columns, and we're going to go over data types in a future video, but for the most part, objects usually mean strings, and then we have other things as well. So int 64 is just an integer. Float is a float, so probably a decimal number. And there are no other data types in this data set. But there are more data types in general, so I will be sure to do a video on here within Jupyter so that we can see all of the columns. So I think it would be useful to see all of these if we'd like to. Even if there are a lot of these to scroll through. So to do this, we can change a setting, and I'm going to come down here to the bottom here, and I'm going to change a setting by saying pd.int dot set underscore option, and within here I will say display dot max underscore columns, and I will set that equal to 85 so that we can see all of our columns, and I will run that. And now if we print out our data frame, so I'm going to go back up here to where we printed out this data frame, and I will rerun that cell. And now if I scroll through these columns, then we can see that now it looks like we actually have these 85 different columns here. So I can keep scrolling, and it didn't just chop us off at that 20 like it was before. Now, obviously, the rows are also being concatenated here, and we definitely don't want to print out all 89,000 of these rows, but there probably are some examples with certain data sets where you might want to see all of the rows as well. So for example, I said that the survey results schema.csv file that was included in our download gives the matching questions for all of these column names here. So if we wanted to see what these column names here mean for this data, then we can load in that schema CSV file as well. So let me do this. I'll go down to the bottom of our notebook, and I will just load this in by saying schema underscore df. Now I don't want to just call this df because we don't want to overwrite our other data frame. And I will load this in just like we saw before by saying pd.read underscore CSV. And this is within the data folder. And this was called survey underscore results underscore schema.csv. So I will run this, and now let's look at this schema data frame that we just loaded in. So here we on this column here, this gives us all of the columns in our other data frame. So we have respondent, main branch, hobbyist, and if I scroll up to that data frame here, I'm going to delete this info here since we no longer need that. If I scroll up to this data frame here, then we can see respondent, main branch, hobbyist. So if we want to know what these mean, then that's what we use the schema for. So we can see that main branch or hobbyist means do you code as a hobby. Main branch means which of the following options best describes. Now it actually concatenates the text too. In order to actually see this the full text, we could either change an option or we could just access this value directly. And I will be showing you how to do that in the next video. But for now, we can see that we can't see all of the rows to the questions that correlate to each column name here. Remember, we have 85 columns, but for here we can only see the first 5, and then we get this ellipses here, and then we can see the last 5. So let's set this up so that we can view 85 rows and then reprint this so that we can see all of these. So back in the same cell where we set our max columns, now let's also add one for rows as well. So I'm just going to copy and paste that, but instead of max columns here, I'm going to have this be max rows, and I will run that. And now we will rerun this schema here, and now we can see that we can see all of the columns and the corresponding question text. So if you wanted to know what any of these columns mean, then this is how we do it. So we can see IT person. The question was, are you the IT support person for your family? So that's probably a yes or no question. You can use our survey data, a specific row for a specific filtering data frame, a certain of our schema, the 85 rows of my survey data every time I want to look at it. But there are a couple of methods that we can use to only see a certain number of rows, which you'll most likely use a lot just to get an idea that your filters and data frames seem to be working correctly. So we can see the first 5 rows, by saying, instead of doing a df here, we can say df.head. And if I run that, then we just get the first 5 rows here. Okay? And you can pass in a value if you want to see a certain number of values. So if you wanted to see the first 10 rows, then we could pass in a 10 to df.head. And this gives us the first 10 rows. So we can see it goes all the way down. Down 0 through 9 there. Now, if you'd like to see the last rows instead of the first rows, then we can use the tail method instead. So if we say df.tail, and we could use it without a number also, but if we pass in a number just like with head, then now we're going to say that we want the last 10 entries here in our data. So those are the last 10 items of our data. Okay, so this is a brief overview of getting Pandas installed and then downloading our data and loading our data into Jupyter and how to read this in. Now, before we end here, I'd like to mention the sponsor of this video, and that is Brilliant.org. So in this series, we've been learning about pandas and how to analyze data in Python, and Brilliant would be an excellent way to supplement what you learn here with their hands-on courses. They have some excellent courses and lessons that do a deep dive on how to think about and analyze data correctly. For data analysis fundamentals, I would really recommend checking out their channel, and that is going to do it for our first Pandas video. I hope you feel like you got a good introduction on how to install Pandas.
Should I choose DevOps as a career route or should I go for SRE? Oh wait, even cloud.
Hey there, how's it going everybody? In this video, we're going to continue learning more about pandas, and specifically we're going to be learning about the data frame and series data types. So like I said in the last video, these are basically the backbone of pandas and are the 2 primary data types that you'll likely be using the most. So in this video, we're going to go over how we can think of data frames and series data types in a different way, and then we'll look at the basics of getting information from these data types. Now, I would like to mention that we do have a sponsor for this series of videos, and that is Let's look at what a data frame is, and then we'll learn more about how we can think about this in terms of a Python. Python object. So we saw data frames briefly in our last video when we checked to make sure that our data was loaded in correctly. So these were the objects that were displayed in Jupyter as rows and columns, basically a table. So let's take a look at what this looks like. So if you were following along with the last video, this is basically the same Jupyter notebook that I had before, except this is just cleaned up a bit. So we're importing pandas here. We are reading in our CSV. Then we are setting some, and the max run with the video so far, the frame here. So where we are printing out df.head rows of our data frame. So you can see that a data frame is made up of multiple rows here, and we also have multiple columns. So in the case of this data, these are survey results, but your data can be, whatever your data is, but it's most likely going to be in rows and columns, kind of like a table. So for this data, with these being survey results, each row is one person who answered the survey, and each question was their answer for that question on the survey. So for example, this respondent number 1 here, they answered that yes, they were a hobbyist. And if you want to know what hobbyist means, then just like we saw in the last video, we can look at our schema data frame. So let me go ahead and print this out here. And let's look at this. So if I look at what a hobbyist is, then we can see that that question was, do you code as a hobby? So that's what this data is, and that kind of gives us an idea of what a data frame is. Basically, a data frame is just rows and columns. But now let me explain how I like to think of data frames using native Python. So if we were only using Python and not using Pandas to store information in rows and columns, then how would we do this? Well, for those of you familiar with dictionaries, you might think that it's a good idea to store information that way. So let me pull up a new notebook here that I have open here with some snippets, and let's take a look at this. Okay, so let's look at this first cell here. So a lot of us are probably familiar with Python dictionaries where we have keys and values. So if I'm representing some data, in this example, it's a person, then we can use a dictionary. So first off, I have a key of first, which is going to be the first name. And then that has a value of Corey. And then we also have keys and values for the last name and the email as well. Okay, so this dictionary here represents data for a single person. But how would we represent data for multiple people? Well, there are probably a couple of different ways that we could do this, but the way that I like to think of this in terms of learning Pandas is to make all of our values in our dictionaries a list. So let's take a look in the second cell here to see what this would look like. So here in the second cell, now we can see that we have a pretty similar dictionary to what we had above. But now, instead of just a single string here for the values, I instead have a list. And our list currently just has one person. But now, since this is a list, we can add more first names and information in here. So the first value of our list is going to be our first person. So if I go to the third cell down here at the bottom, then now we can use this as an example to see what this would look like with multiple people. So the second value in our list will be our second person, and the third value in the list will be our third person. So if we look here, we have people, we have a key of first. So if we want the second person here, we go to the second value, that's Jane. The last name is Doe, and the email, go to the second value here, is janedoe@email.com. If you want the third person, that would be John, and then third value and last would be Doe. Then third value in email is johndoe@email.com. So we can kind of think of this like rows and columns. The keys are the columns and the values are the rows. Now, if you look up the definition of a Pandas data frame online, then you'll see a lot of definitions that just say something like it's a two-dimensional data structure. Now, that might sound a little confusing, but in layman's terms, that basically just means rows and columns. Okay, so like I said here, the key for email here would be our email column and contain all of the email values. And if we wanted to see the email column, then we can just access that key. So if I come down here actually, let me run all of these really quick here. I think I opened this up without running these, so I want to make sure that we have this registered. Okay, so if So if I wanted to see that email column, then I could simply say people and then access. The reason that I wanted to show you this is because I feel like this really helped me in terms of how I think about data frames. So data frames are very similar to this, but with more functionality than what we have here in standard Python. Now, we can actually create a data frame from this dictionary and see what this looks like. So let's do that and look at some basic data frame functionality. And then we'll look at this more using the Stack Overflow data from the last video. So here in this bottom cell, in order to create a data frame from the information that we have here, I'm going to go ahead and import pandas. So I'm going to say import pandas as PD. And now we can create a data frame actually using this dictionary that we have up here. So to do that, I can just say df is equal to pd.dataframe and check the casing there. That's a capital D and a capital F. And then we'll just pass in that dictionary that has values as list. So if I run this, and that seemed to run okay without any errors, and now let me just print out df here. And if I print that out, then we can see that now our data frame is representing this in a way to where we do have rows and columns that we can visualize. So we get these people printed out in a nice table of rows and columns. Now we also have these over here to the far left that don't have column names, this 0, 1, and 2. Now this is an index. Now I'm not going to go much into indexes right now because that's what the next video is going to cover, but basically it's a unique value for our rows. Now, it doesn't need to be unique, but again, we'll talk more about that in the video specifically on indexes. So now that we have a bit of an idea of how to think about data frames, now let's take a look at how to access information here within the data frame. So first, let's just access the values of a single column. So just like we did with the dictionary, we can access a single column just like we were accessing the key of a dictionary. So just like I did people and email up here, I can do very similar down here and just say that I want that email column of my data frame. Now, that's not actually a key. That is going to access the column of a data frame, but we can see here that we get all of the emails back from that data frame. So again, I do want to emphasize that I only used the pure Python example so that we could get an idea of how to think about a data frame. But like I said, a data frame is much, much more than just a dictionary of lists. lists. So for example, we can see that when we displayed the email column here, it doesn't look the same as when we displayed the list of values from that dictionary. And that's because this is actually returning a series. And we can see this if we check the type. So if I check the type of this email column here, so let me run that, we can see that this is pandas.core.series.series. So this is a series object. So what is a series? So a series is still basically a list of data, but just like with a data frame, it has a lot more functionality than just that. Now, if you look up the definition of a series online, then you'll see a lot of definitions that just say it's a one-dimensional array. And that might sound a little confusing, but in layman's terms, that basically just means that it's rows of data. So again, you can think of a data frame as being rows and columns, and a series as being rows of a single column. So a data frame is basically a container for multiple of these series objects. So again, that's important. So let me go over that one more time. So we can see that a data frame here is two-dimensional because it has rows and columns. So we can see here that it has first name, last name, email. Now, whenever we access just the email, then we can see that we get all these emails here. Now, this is a series. And I said that a data frame basically is a container for multiple series objects. So we can think of this email column here as a series, this last column here as a series, and this first column as a series. And also we can see where we printed out this series here for the emails, we can see that this series also has an index as well, just like our data frame did. So this index is over here on the left, the 0, 1, and 2. Okay, so we can access a single column of a data frame like we're accessing a key, just like we did here in this cell. But you might also see some people use dot notation to do the same thing. So you might see some people do it like this. So they might do df.email. And if I run this cell, then we can see that, let me get rid of this cell here. And just so we can compare these two, we can see that this gives us the same thing. Whether we access this like a key or whether we use dot notation, this returns the same series object of the email values. Now, whichever way that you want to do this is really just a personal preference. I actually prefer the first way of using the brackets, and there are a couple of reasons that I prefer to use that over dot notation. First is that I like using the brackets because there's a chance that one of your columns is named the same thing as one of the attributes or methods of a data frame. And if that's the case, the case, then using the dot notation might give you some errors. So for example, if a data frame has a method called count. So if you had a count column using dot notation count method from data, we have one in this specific data frame, but if we you might see them access columns in using dot notation. So you need to know that it's at least a possibility. And again, that doesn't mean that they're doing it wrong. It's just a personal preference. I just prefer using the brackets. Okay, so I said that data frames have a lot more functionality than what we saw using, standard Python. So let's look at some other stuff that we can do here. So let's say that we wanted to access multiple columns. Now, in order to access multiple columns, we can use the bracket notation and pass in a list of the columns that we want. So if I wanted both the last name and email columns, then we could say df and use our brackets just like we saw before. But now I'm going to put in a set of inner brackets here as a list of columns that I want to access. So for the first value, I'll put last for the last name. And for the second value, I'll put email for the email. So if I run this, then we can see that now we have a data frame returned here of the last column and the email column. Now, I want to emphasize again here that I passed a list inside of these brackets here. So there are two pairs of brackets. You can't leave off the inner brackets because you'll likely get a key error because Pandas will think that you're passing in both of those strings as a single column name. And another thing that I want to point out here is that now that we're getting multiple columns, this can no longer be a series because remember, a series is basically a single column of rows. So when we get multiple columns like this, it's just returning another data frame. And in this case, it's a filtered down data frame with just these specific columns. So we filtered out the first name column here and we just have the last and the email. Okay, so that's how we get a specific column or multiple columns, and we can slice these as well, similar to how we slice a list. But I'll show that on our larger Stack Overflow dataset here in a second. Now, if you have a lot of columns and want to see all of them easily, then we can just grab the columns specifically by saying df.columns, and we can run this, and we can see here that this gives us all of our columns here. So our columns are an index of first, last, and email. Okay, so now we've seen how to get a column, but how would we get a row? So in order to get rows, we can use the loc and iloc indexers. So that is loc and iloc. So let's take a look at these. So first, let's take a look at iloc. So iloc allows us to access rows by integer location, hence the name. Iloc is integer location. So if I wanted to get the first row, then we can just say df.iloc and then use brackets here to, since this is an indexer, use brackets and pass in a 0, and that will give us the first row. So if I run this, then we can see that the first row has a first name of Corey, last name of Schaefer, and email of CoreyMSchaefer@gmail.com. So what that did is it returns a series that contains the values of that first row of data, which, like I said, is the first name, last name, and email of the first person in this example. And again, we haven't discussed indexes yet. That will be in the next video. But the index here is the column names so that we know what those values are. So up here, our index was 0, 1, and 2. But whenever we're actually accessing a row, it's going to set that index to the column name so that we know what those values are. Because if this just said 0, 1, and 2, then we might not know what these are. And just like when we selected multiple columns, we can select multiple rows as well by passing in a list of integers. So if I want the first and second row, then we can just say, and again, this is going to be a pair of brackets within these brackets because we're passing in a list to our index here. And I'm just going to pass in a list of 0 and 1. So if I run this, then we can see that now we get the first 2 rows of data. And again, be sure to pass in an inner list inside those brackets so that it does what you expect it to do. And also we can see that now we're getting a data frame with these multiple rows. Now, with these iloc and loc indexers, we can also select columns as well. And that is going to be the second value that we pass into these outer brackets. So if we thought of iloc and loc as functions, then we can think of the rows that we want as the first argument and the columns as the second argument. So let me show you what this looks like. So here we have our inner bracket. Those are the rows that we want. But now, after that list, we can put a comma, and now we can specify the column that we want. Now with iloc, we can't specify an actual column name because these use integers, integer locations. So these are for integers only. So remember, our first name is the first column, the last name is the second column, and the email is the third column. So if we wanted to grab the email address of the first 2 rows, then we can grab the column at index 2, which will be the third column since all of these start at 0. So if I was to pass in a 2 here and run that, then we can see that now we get the email addresses of these first 2 rows. Okay, so that's iloc. So now let's look at loc. So with iloc, we were searching by integer location. With loc, we're going to be searching by label. And when we're talking about labels for rows, these will be the indexes. And again, we don't have custom indexes right now, so this index is just a default range of integers. So at the moment, this will somewhat be similar with iloc, the iloc indexer, but we'll look at uses or use cases with loc with actual labels in the next video when we cover indexes. So real quick, let's look at our entire data frame again. So I'm just going to print that out down here. So like I said, over here on the far left, these are our indexes. So these are the labels for that row. So if I want the first row, then by default, this just has a label of 0. So I can say df.loc and pass in a 0 there. And if I run that, then we can see that we get that row with that label of 0. And again, I know that that looks similar to iloc at the moment, but we'll see how to use indexes with labels in the next video. And just like with So now let's look at loc. So with iloc, we were searching by integer location. With loc, we're going to be searching by label. And when we're talking about labels for rows, these will be the indexes. And again, we don't have custom indexes right now, so this index is just a default range of integers. So at the moment, this will somewhat be similar with iloc, the iloc indexer, but we'll look at uses or use cases with loc with actual labels in the next video when we cover indexes. So real quick, let's look at our entire data frame again. So I'm just going to print that out down here. So like I said, over here on the far left, these are our indexes. So these are the labels for that row. So if I want the first row, then by default, this just has a label of 0. So I can say df.loc and pass in a 0 there. And if I run that, then we can see that we get that row with that label of 0. And again, I know that that looks similar to iloc at the moment, but we'll see how to use indexes with labels in the next video. And just like with iloc, we can also pass in a list to specify multiple rows. So if I wanted the first and second row, then just like with iloc, I can pass in an inner list here. So let's say that I want the first row and the second row. So I'll run that. We can see that now we get the first and the second row. And again, now we can see that we are getting a data frame back now that we have multiple rows. And just like with iloc, we can also pass in a second value into our indexer to select specific columns for these rows. Now with iloc, we used integers to select the columns, but now that we're using loc, we can use labels. So if we want the email column of these first two rows, then now we can just pass in a value of email. So if I run that, then we can see that now we get the email value of these first two rows. Now, I didn't show this with iloc, but we can also pass in a list for the columns as well. So if I want the last name and the email for these rows, then instead of just passing in a string as this second value here, then we can pass in a list of strings of the columns that we want. So I'm going to wrap this in brackets here. I know that this can get a little confusing with all these inner brackets, but let's say that we want email and we want last name. So if I run this, then now we can see that we got these specific columns here, email and last name, for these specific rows, the row with label 0 and the row with the label of 1. And also notice that the columns display in the order that we used in our list up here within loc, which is a different order from our original data frame. So up here, it's first, last, email, but we asked for email and last, and it gave us back in that order of email and last. Okay, so now that we've seen the basics of grabbing certain rows and columns from a small data set, now let's go back to our data set from the last video and see how we grab some rows and columns from the Stack Overflow data set. So I'm going to go over here to back to our Pandas demo here. And again, just a quick overview of the data that we have here. We're importing Pandas. We have DF as our main survey results here, our schema DF as our schema results. We are setting some options here. This is what our main data frame head looks like, which is the first 5 rows. And then this is what our schema looks like. So I'm going to go down below our schema here. And now let's mess around with this a little bit. So let's go over a bit of what we learned and pluck out certain rows and columns. But first, let's see how many rows and columns that we have in this data frame. Now we Now, we saw a couple of different ways to do this in the last video, but the easiest way to do this is in columns. But first, let's see how many rows and columns that we have in this data frame. Now, we saw a couple of different ways to do this in the last video, but the easiest way to do this is to use the shape attribute. So if I say df.shape and run this, then we can see that we have 88,000 rows and 85 columns. So let's grab all of the responses for the hobbyist column. So again, what I'm trying to do here is if we look at rows and 80 and run this, then we can see that we have 88,000 rows and 85 columns. So let's grab all of the responses for the hobbyist column. So again, what I'm trying to do here is if we look at our main data frame, I want to grab all of the responses for this column right here, hobbyist. Okay, so how would we do that? Now, if you remember, if you want to see what columns are available, then you could just say df.columns to see all of these. We can see that these are kind of long. We have 85 here, but here we have hobbyist, which is the one that we want. And that is the question where people answered if they code as a hobby or not. And in the next video, we're going to cover indexes. I'll show how we can, search a schema data frame to find exact questions so that we can see what questions are what specific columns in the data frame. But right now, let's just grab those hobbyist responses. So if you remember from that small data set that we just saw, in order to grab that hobbyist column, we can just access that like a key. So if I say df and then pass in hobbyist there, then we get a series of all of those responses. And luckily that doesn't display the entire 89,000 rows in our browser here, but we do get the head and the tail of that data to get an idea of what those responses look like. Now, real quick, let me show you something that we'll cover more of further into the series, but I want to give you an idea of how powerful something like Pandas is. So let's say that we wanted to know how many of these responses were answered yes and how many were answered no. Now, if we were using regular Python, then we might import the counter class or write a quick function or a loop to do this. But Pandas has so much of this stuff already built in. So to get the count of unique values in this column, I can just use this value counts method to calculate this. So right up here, I can just tack on a method of value underscore counts. Now, again, this is going to be for a future video, but I just want to give you an idea of what Pandas can do. So whenever I add this value counts method, we can see that out of this series that we returned here for all of our answers for this hobbyist question, the value counts are 71,000 people said yes, they do code as a hobby, and about 18,000 said no, they don't code as a hobby. And again, we'll cover more of this in future videos when we learn more about analyzing data in depth, but I wanted to give you a quick taste as to why it's beneficial to even learn Pandas like we're doing here. It makes this type of stuff really easy, and we could go further and plot that out and everything. Okay, but with that quick sidetrack out of the way, let's keep going and go over the other things that we learned earlier. So we got a column here. So let me get rid of that value counts. So we have our column here. So now let's grab a specific row and a specific column. So we got a column here. So let me get rid of that value counts. So we have our column here. So now let's grab a specific row and a specific column. So let's grab the first row, and we'll also grab that same hobbyist column for that row. So how do we grab? And we'll also grab that and a specific column. So let's grab the first row, and we'll also grab that same hobbyist column for that row. So how do we grab rows? So remember, if we want to grab rows, that we use the loc or iloc or indexers. So I'm going to go ahead and use loc because remember index and hobbyist, then we can see that their answer to that whether they code as a hobby is yes. And also, like we saw earlier, I can also pass in a list of multiple rows or multiple columns to get the exact rows and columns that we want to see. So to get the first three responses for the hobbyist column, then instead of just passing in a single value here, then I can put in some inner brackets here and pass in a list of multiple rows. So if I pass in a list of 3 rows here and run this, then these are the first 3 results for that hobbyist column. Now, one thing that we haven't seen yet is that we can also use slicing to grab multiple rows and columns as well. Now, if you're familiar with list slicing, then this is pretty much the same thing. The only difference is that our last value is going to be inclusive, at least with loc. So if we wanted the first 3 rows, then we could say that we want from 0 and then slice to the index of 2. And if I run this, whoops, and I accidentally made a mistake here. Actually, whenever we're using slicing, we do not wrap these in brackets. So I'm going to take that out. So for our first value, we're just saying we're no longer passing in a list of values. We're just passing in this slice of 0 and then colon 2. So if I run that, then we can see that now we get the same result that we got before. And we can do this with the columns as well. So right now we're only getting the hobbyist column, but let's go back and look at our columns and see what columns come after the hobbyist column. So up here, these are all of our columns here where we printed them out. So let's look at a few columns after hobbyist here. So we have open sourcer, open source, employment. So let's say that we wanted to get all of the columns from hobbyist all the way up to this employment column. So to open source, employment. So let's say that we wanted to get all of the columns from hobbyist all the way up to this employment column. So to do that, I'm just going to copy that. We can come down here and we can just pass in a colon and then employment, and that'll do a slice from hobbyist to employment. Now, I also want to point out that this is the reason that slicing is inclusive for these values, because imagine how much of a pain it would be if we wanted all of the columns from hobbyist to employment, but the last value here wasn't inclusive. And we had to come up here and say, well, if I want from hobbyist to employment, then I really need to pass in, hobbyist to country, and country's not inclusive. That would just be way too confusing. So it's so much easier for this to be inclusive here. So if you were wondering why they did that, then that's why they do it. So if I run this, then we can see that now we get these first 3 rows here. And for the first 3 rows, we get all of those responses for the columns of hobbyist, open sourcer, all the way up to employment. So now we've seen an overview of everything that we've learned about exploring our data frames and series objects so far, and how we can pluck some, basic information out of these. Now, there's still tons to learn about data frames and series objects, and we'll continue learning more about these throughout the Pandas series, since these 2 data types are the main data types that we'll be using in Pandas. So we'll be learning more about advanced filtering, queries, how to see which data type each column of our data contains, and a lot more. Hey there, how's it going, everybody? In this video, we're going to be learning more about indexes. So we've seen basic default indexes in previous videos, but in this video, we'll learn how to set custom indexes and the benefits of doing this. Now, I'd also like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring this series.
Did you know you can AFK Bloods and Zaya whilst learning to code in Python? Go to boot.dev. We've known our students to pull it off.
Hobbyist, open sourcer, all the way up to employment. So now we've seen an overview of everything that we've learned about exploring our data frames and series objects so far, and how we can pluck some, basic information out of these. Now, there's still tons to learn about data frames and series objects, and we'll continue learning more about these throughout the Pandas series, since these two data types are the main data types that we'll be using in Pandas. So we'll be learning more about advanced filtering, queries, how to see which index here, and I'm just going to list. So for example, we can see that when we displayed the email column here, it doesn't look the same as when we displayed the list of values from that dictionary. And that's because this is actually returning. Again, we don't have custom indexes right now, so this index is just a default range of integers. So at the moment, this will somewhat be similar with iloc, the iloc indexer, but we'll look at uses or use cases with loc with actual labels in the next video when we cover indexes. So real quick, let's look at our entire data frame again. So I'm just going to, when we cover display in the order that we used in our list up here with
Let's start with this problem. Find the mean, median, mode, and range of the following data set. Now, the first thing that I would recommend doing is arranging the numbers in increasing order. In order with that mean, the middle and t middle mean the this problem for most median number the same. As you can see, we had previously equal to this.
इधर आओ, असली स्टॉक मार्केट रिसर्च देखनी क्या होती है? आ जाओ.
This is my 150 book stock market collection, and these
Have 11 plus 15 plus 8 onto this, but this time 8 divided by 2. So now as we see, what about the range 8? Now we're going to break the highest and an end. Make about finding the quartiles and the interquartile range. So what I'm going to do right now is I'm going to make basically a number line with a beginning and an end. And let's say this number line represents our data. The lowest value is known as the minimum. The highest value in our data set is the maximum. Now we're going to break this number line into 4 equal parts. The first part is known as Q1. This is the first quartile. The second one is Q2, the second quartile, and then this is the third quartile. So let's say if the data was normally distributed, this would be at a 0% level, this would be 25, this would be at a 0% level, this would be 25, 50, 75. This is the first quartile. The second one is Q2, the second quartile, and then this is the third quartile. So let's say if the data was normally distributed, this would be at a 0% level, this would be 25, 50, 75, and then this will be 100. So you could see how the quartiles are related to each other respectively. Now, how do we go about finding Q1, Q2, and Q3? How do we do that? Q2 is basically the median of the entire data set. Q1 is the median of the lower half of the data set. And Q3 is the median of the upper half of the dataset. Now, the interquartile range, represented by IQR, this is the difference between Q3 and Q1. So once you find Q1 and Q3, you can now calculate the 5, 50, 75, and then this will be 100. So you could see how the quartiles are related to each other respectively. Now, how do we go about finding Q1, Q2, and Q3? How do we do that? Q2 is basically the median of the entire data set. Q1 is the median of the lower half of the data set. And Q3 is the median of the upper half of the data set. Now, the interquartile range, represented by IQR, this is the difference between Q3 and Q1. So once you find Q1 and Q3, you can now calculate the interquartile range. Now, the next thing that I want to mention is the ability to find or identify if a number in a dataset is an outlier. So here's what you need to know. It's not going to be an outlier if it's within this range. If it's between Q1 minus 1.5 times the IQR, so that's the lowest that it can be, or the highest it can be is Q3 plus 1.5 times the IQR. So if you have a number that is within this range, it is not an outlier. But if you have a number in the data set that is outside of this range, then that number is an outlier. So let's work on an example. Let's say we have the numbers 7, 11, 14, 5. So let's work on an example. That number is an outlier. So let's work on an example. Let's say we have the numbers 7, 11, 14, 5, 8, 27, 16, 10, 13, 17, and 16.
Hi, I took more than 300 interviews when I worked for Facebook. 80% of people I interviewed for problem solving failed the interview. 90% of people I interviewed for system design failed the interview. If you want to learn why people fail interviews, what to learn, where to learn it from, and why even learn that, come join me in my free class by clicking on the link below.
Go ahead and identify Q1, Q2, and Q3. Calculate the interquartile range, the IQR, and determine if there's any outliers in this data set. Feel free to pause the video and use what you know to try it. Now, as always, the first thing we should do is organize the data. The lowest number is if we find the median of the entire data set, which is going to be Q2. So we could eliminate the first two numbers, the first and the last number, and then the next two until we get in the middle. We're going to get rid of Q2, number for the left side and of the data. So just keep that up. Q1 is the median of the lower half of the data set. So what is the median of those 5 numbers? The median is simply going to be the middle number of those 5 numbers. So Q1 is 8. Now, what is the median of the upper half of the data set? 11 IQR. So we said it's the difference between the third quartile and the first quartile. So it's going to be 16 minus 8, which is 8. And so that's how you could find the interquartile range of a data set. Now, what about the presence of any outliers? So looking at these numbers, do you think we have a number that really stands out that doesn't belong? Right now, 27 appears to be very far off from all the other numbers. So do you think 27 is an outlier? Well, let's find out. So let's write down what we know. The presence of an outlier is based upon this range. It's Q1 minus 1.5 times the IQR, and this is 16 plus 12. And plus 12 is 28. 8 minus 12 is negative 4, and 16 plus 12 is 28. So now looking at what we have, is 27 an outlier based on this range? Because 27 is between negative 4 and 28, 27 is not an outlier. Now let's talk about how we can create a box and whisker plot. The reason why we want to talk about this now is because it's related to the values of Q1, Q2, and Q3. So typically, a box and whisker plot looks something like this. Assuming if there's no outliers, this is going to be the lowest value. On the right, we're going to have the highest value, or the maximum. And then this line here represents the value of the first quartile, which is the 25th percentile. In the middle, we have Q2, the second quartile, which is the 50th percentile. And then this is Q3, the 75th percentile. And so that's the basic shape of a box and whisker plot. Now, what about if we have an outlier? Let's say if we have one to the right. Then this will no longer be the maximum. The outlier is shown as a point. It's outside of the box and whisker plot. Now, if it's on the left side, this will no longer be the minimum, and that will be the outlier there. So let's work on an example. Let's say we have the numbers 16, 18, 28, 13, 50, 31, 25, 22, and let's say another 18, 23, 29, 31, and 38. Actually, I wrote down 31 already. Let's make this 38. So we have 12 numbers. Using this data set, go ahead and find the interquartile range, Q1, Q2, Q3, identify the presence of any outliers, and then using all of that information, construct a box and whisker plot. Feel free to pause the video if you want to try that yourself. Now the first step, as always, is to write the numbers in increasing order. So we have 13, 16, 8, then there's another. Now, what else? Median between upper half. and the first is minus 1.5. Q is, so Q1 is, I write that down. So it's maximum 50.
Welcome to the 16th Google I/O. I want to thank our fantastic developer community, all millions of you around the world, for choosing to build with Google. At Google, we're on a mission to make generative
The number line is outlier is in this region. Now Q1 is 18, Q3 is 30, but we also need to write where not Q4, but where Q2 is. Q2 is 24, which is around here. So this is Q1, that's 18, Q2, and Q3. So the length of the box represents the interquartile range, which is 12. That's 30 minus 18. And so here is the minimum, and this is the maximum, which is the outlier. But that's how you can construct a box and whisker plot given a data set. Now the next topic we need to talk about is skewness. So let's say we have this representation of our data. And notice that it is symmetrical. This line represents the median. And if you have a data that is perfectly symmetrical, the mean, this is the sample mean, it's going to be equal to the median. Now, the box and whisker plot will look something like this. Q2 is going to be right in the middle of Q1 and Q3. So notice that the box plot is evenly distributed. The left side is the same as the right side in length. And also, these lines are equal in length. So that represents a symmetric distribution. Now, what if it's not symmetrically distributed? What's going to happen in that case? There are two possibilities. The data can be skewed to the right, or it can be skewed to the left. So which one would you say this particular shape represents? Would you say it's skewed to the right or skewed to the left? Notice that we have a tail that extends towards the right. So this particular data, or this graph, we say that it's skewed to the right. Now, what is the relationship between the sample mean and the median in this case? So the median, the middle portion of the data, will be somewhere in this region, and the sample mean will be to the right of the median, since it's skewed to the right. So the mean will be greater than the median in this case. By the way, whenever you have a shape that's skewed to the right, some textbooks will refer this as a positive skew. And it makes sense because positive numbers on a number line will be on the right side. Now, you need to be familiar with the box and whisker plots for this type of distribution. So here's one example. Notice that the right side of the box is longer than the left side. So this tells us that Q3 minus Q2 is greater than Q2 minus Q1. And so in that case, looking at the box and whisker plot, you can see that it's skewed to the right. Now sometimes these two boxes may be equal in length. Nevertheless, this side might be longer than this side. So even if the boxes are of the same length, if this side is longer, it will also be skewed to the right. Now what about if it's skewed to the left? In this case, the graph is going to look something like this. Let me try that again. So notice that the tail is on the left side. So in this case, we have a negative skew, or we could say that is skewed to the left. Now the median will be somewhere in this region, and the mean is going to be to the left of the median since it's skewed to the left. So the sample mean is less than the median. Now how can we represent this using a box plot? Well, here's one possibility. So in this case, Q2 will be closer to Q3 in the box plot. So as you can see, the left side is longer than the right side. So we can say that Q2 minus Q1 is greater than Q3 minus Q2 in this case. Now, if the boxes are equal in length, you can also tell that we have a negative skew if the left side of the box plot is longer than the right side. So that's another indication that the data is skewed to the left. Now, there's some other things that you need to know if you're going to take a statistics course. And you need to be able to create a dot plot. So let's say if you have the numbers 5, 8, 3. With this information, how can we construct a dot plot? Well, we could begin by drawing a number line. So let's say this is 0, 1, 2. We could stop at 8 since 8 is the highest number. Now the first number is a 5. So all we need to do is draw a dot above the number 5. And then let's put the dots one at a time. So the next number is an 8. So we're going to draw a dot at 8. So 1 and then a 5. So notice that we have a second 5. All we need to do is draw another dot above the first one. And then it's a 3, 2, and another one, and then 8, and then 5. So that's how you can make a dot plot. Now, using this dot plot, which number is the mode? What would you say? Now, if you recall, the mode is the number in the dataset that occurs most frequently. So in this case, it's the number with the most dots. So the mode for this data set is 3. By the way, if you haven't done so already, don't forget to subscribe to this channel and click on that notification bell. Now let's talk about how we can make a stem and leaf plot. So let's say we have the numbers 4, 9, 13, let's say, and then 56. How can we make a stem and leaf plot with this data? So the first thing we need to do is we need to write 2 columns. On the left, it's going to be the stem, and on the right, the leaf. So the first number is 4. So for the stem, we're going to write 0. And for the leaf, we're going to put 4. The next one is 9. So we're going to write or represent 9 as 0, 9. So we have 0 on the left, and then we're going to put 9 on the right. The next number is 13. So the first digit is a 1. And now put number, it's going to be 8. Let's say another 38. And then 56. How can we make a stem and leaf plot with this data? So the first thing we need to do is we need to write two columns. On the left is going to be the stem, and on the right, the leaf. So the first number is 4. So for the stem, we're going to write 0. And for the leaf, we're going to put 4. The next one is 9. So we're going to write or represent 9 as 0, 9. So we have 0 on the left, and then we're going to put 9 on the right. The next number is 13. So the first digit is a 1. The second digit we're going to put in the second column. Now we have another 13. So all we got to do is add another 3. Now for 17, we need 1 and 7. We already have the 1, but we need to write the 7 to the right side.